Good morning. Thanks for joining us here today. The great news is we're here for somewhat of a freestyle panel discussion, no slides, and what we've done is we actually found some really smart folks, well-known folks in the industry to join us and provide some opinions. So what we plan to do is we'll have each of our panelists introduce themselves, and then I'll throw out a question or two and get the dialogue going, and we'll leave some time at the end. If you all have questions that you want to ask of the panelists, it's free form. Just draw my attention. I'll come out with the mic so that we can hear the question, and then we'll continue the dialogue real time and live. So thanks again for being here. I'm Scott Gnau, CTO of Hortonworks, and the only value I'm going to provide today is keep the conversation going and bring the mic out if you all have some questions for our panelists.
Hi. Not sure this is on.
Here.
Hi. Hi, everyone. My name is Laurent. I work for Ovum, the research firm. I specialize in analytics, so that's visual analytics and more predictive analytics as well, and enterprise data culture, and I'm based in London.
Morning, everyone. Pankaj, Sodhi with Accenture. I lead the big data practice for Accenture across Europe. My background's in data management, BI, and analytics, and I work with clients across industries, helping with the deployment of big data technologies alongside more conventional technologies and organizations.
Well, good morning from me as well. I'm George Anadiotis, and most people know me from my ZDNet work, where I cover big data, AI, machine learning, innovation, and so on. And I also run my own consultancy as an independent analyst to link data orchestration, and I happen to live right around the corner here in Berlin, so lucky me.
Great, thanks. So just to kick things off, and for those of you who attended the opening session, you're probably aware, certainly I have an opinion about cloud and data and analytics and all that kind of stuff. So what I thought we'd do, maybe open up with the panelists and kind of get their feedback on what they're seeing in and around data analytics and use cases in the cloud, hybrid use cases, any tips or techniques or warnings about the adoption of cloud technology that we're seeing in our space.
Okay, since I got a microphone, I guess I'll start. So actually, I'll start at where you ended, so warnings. I don't know how many of you have seen the latest report that came out from Gartner, actually. And one of the things that they mentioned there was, it's cloud adoption is picking up, that much we knew already. But one of the warnings they issued is that the fact that this could actually be a caution for enterprises, because they're basically outsourcing something that's quite important. So you have to be quite careful on, balancing out the facility that this can provide as a commodity, using the cloud as a commodity, and the fact that, you're outsourcing something that can have a quite an impact. So that's one of the points I wanted to make. And the second one, I had the privilege of discussing with someone who's a leader in AI and machine learning. So the mastermind of Deep Learning for J, one of the leading frameworks for deep learning. And one of the points that he made, actually the focal point of our discussion was the strategy of cloud players with respect to machine learning. And his key takeaway was that, well, the reason that each and every major cloud provider has a machine learning or deep learning library is because they see that as a way to drive traffic and therefore revenue in their clouds, because machine learning requires a huge amount of data and also a huge amount of computation. So by driving data and compute there, obviously they're looking to increase the revenue. So that's two key points that I think should be noted.
Thanks. So I'll answer the question about the different, use cases we're seeing moving towards the cloud. So I think one of the obvious ones that even Bernard mentioned this morning was machine learning in spiky workloads, where there's a need for some fairly significant compute, where you don't want to pay for that kind of capacity on-prem. So those kind of elastic workloads with more ephemeral workloads, that's an obvious one. But more interestingly, in terms of now optimizing on-prem and cloud-based deployments in a hybrid architecture, I think there's about 3 or 4 different archetypes that we're seeing. One is, like in the past, oftentimes a given sort of data set or a use case may have been implemented using ETL tools and data warehousing platforms, where something like a Teradata or Netezza was always the answer with an ETL tool. We're now starting to see some of those workloads being, let's say, opportunistically being moved towards cloud-based deployments. So that's more of a sort of an optimized kind of an archetype. We're also seeing an extend archetype where, for example, for some of the more semi-structured data or low latency workloads, in terms of trying to move them off on-prem and move them onto the cloud, that's one. And then quite a few interests in terms of now really rebalancing TCO. So as organizations are coming up with large sort of CapEx investment points, starting to look at what data are actually being utilized on the platforms. Is it age data, isolated data sets, and can we move them, for example, onto the cloud? And then getting into discussions such as, do we go with an IaaS-based play with some best-of-breed tools? Is it going to be a PaaS-based play? So I think these are some of the different patterns that we're seeing. And I think one of the points of caution, picking up from what you said, is some organizations are running sort of almost like a big bang and trying to really rebalance from on-prem into the cloud. And one of my suggestions always is, let's work out the data usage patterns. So for example, if it's a batch-oriented workload, let's actually do a pilot, standardize that, and then you've got a set of tranches you can do on the back of it, pick out the different tooling that you're going to use, and at least the bare minimal platform operation standards for cloud deployment. So sort of like a foundational release, work on that. Then you can bring in things like micro-batching or streaming, and really establish these patterns, and then you can have a lot of options for how you then optimize workloads across on-prem and cloud.
Well, there's a lot that's being said. So I guess maybe what I'll add, and jumping on what you said earlier, would be the key term in all this would be hybridity for me. So the ability to meet the enterprise both on-premise or in the cloud, depending on where their workload is ran. I think it provides a lot of flexibility, and that's important for, I guess, two main things. The first thing is the journey to the cloud is well, never ending, sure, and we're definitely not near the end. So a lot of data is still on-premise waiting to be migrated. So obviously you need hybridity to meet your customer where he is. The second thing is also some data will most likely stay on-premise for privacy and regulation reasons. I'm sure we're going to come around to that. But if any one of you either works for a bank or with banks, and I'm sure you guys have, they tend to be quite conservative, and they want some data on-premise. They're happy for some data to go in the cloud, but hybridity is probably the key operating word in all this.
Great. So it seems some consensus there, and actually in some of the discussion, y'all brought up machine learning and a little bit of AI, so I'll kind of segue into that. In the machine learning AI, obviously a lot of excitement, a lot of buzzwords, that tends to show up in a lot of press releases because it's exciting and it captures people's imagination. It'd really be great to get your feedback on what you think is real, what's happening, what's tangible. What does 18 look like? What does 19 look like in the machine learning AI space?
I guess I'll do the honors. Well, I mean, I think we're still quite early in the AI hype cycle, if you will. Personally, I'm not a huge fan of the term AI, just because it's an umbrella term. So in this case, I guess we can talk about machine learning. There's some concrete use cases that are starting popping up here and there, and usually that's a good sign. It's quite exponential. So once some enterprises start having real use cases, there's this kind of bandwagon effect with more and more concrete use casing popping up. I guess prevalent on my mind is predictive analytics at the minute, mainly because that's in my coverage area. So there's a lot of work done around that. I think the key issue with machine learning right now is in terms of people. So there is both a skill issue in trying to get the right people, but also getting the entire enterprise to collaborate. So whether that's between the IT department, the business analyst, and of course your data team, whether that be a data science or just analyst team.
I'll refer to a couple of different use cases across industry. So for example, in retail, for machine learning, we're seeing a lot more predictive models coming up, for example, for forecasting and supply chain analytics. And I think what's there now, which wasn't there in the past, was the ability to actually bring together some fairly large data sets And as I think Bernard was saying in his talk earlier, looking at the variety of the data coming through. So, for example, pulling in weather data, and then looking at, for example, third-party data, and then building some set of predictive models, and being able to actually test and deploy a lot of these models with sort of a low-regret kind of a TCO-based structure. So I think that's one example. We're seeing some interesting use cases actually in the government and in the policing workforces, where, for example, for preventive crime maintenance, and how can you actually detect potential crime actually happening and then deploy your workforce? We're seeing some very interesting work happening there with some of our UK police workforces. And then also, for example, in the banking industry with AML transaction monitoring, how to actually reduce the number of false positives and then really drill down on potentially sort of fraudulent transactions. So there's a lot that's coming up now. I think some of the challenges are, well, first of all, there is a tendency to just try to ingest all kinds of data without necessarily knowing how you would use it. And I think the balancing act there needs to be, I would say, some fairly savvy data scientists who've got a good handle on the industry to actually know what questions to ask. And sometimes we see the scenario where data are being ingested without the tooling or the skills to bring to bear to ask the relevant questions. That's one. And I think oftentimes a lot of the machine learning use cases, they demonstrate some outcomes and value in a POC scenario, but then to part to production is often quite challenging. So oftentimes successful POC is not necessarily going into production, and that's where, to your point, Laurent, having the right mix of teams, sort of data engineers, scientists, DevOps folks working together to have a fast path to production and a feedback loop that then helps validate and retrain and test the models is quite important.
Yeah, actually, I'll start with definition. I'll agree with you, Laurent, that, well, actually, yeah, machine learning and even deep learning and AI are not synonyms. So AI is a much wider field that covers many approaches. But okay, for the sake of argument, let's stick to machine learning for the time being, at least. And I would say that for me, actually, the biggest roadblock there, I mean, it's very real. It's very much happening, yes. But the biggest roadblock for most organizations would be the actual people that would do that, not so much the data. There is infrastructure. We have, cloud, and there's libraries, many of them open source, and there is, the things, the actual hardware and software you can use to do that. The thing that's actually missing is, as is typically with data science as well, and these two are very much connected, the people. So there are two approaches I see being used to sort of counter that. So one is embedded analytics, actually. So we already have tools that go all the way up even to predictive analytics, as Laurent mentioned. And in that part, vendors are actually using machine learning, embedding it in their tools, so that you don't have to build it from scratch. You just keep using the tool that you have always been using, and just are able to use the capabilities that the vendor has plugged in for you. So that's one. And the second one is, I already referred to that, well, cloud libraries. So since the applications are moving to the cloud and therefore the data are moving in the cloud, the libraries are also there. So if you have externalized, let's say, some of your operations in the cloud, then the cloud providers make sure that you can directly connect your data to their libraries and do your machine learning in the cloud. So these are two of the most prevalent things I see happening today.
Great, and I'll just build off of that, and this was not in our prepared notes, so I'll warn you all, right? But I heard, through this, I heard a consistent theme of, collaboration, people needing to work together in different ways to be effective. Certainly having hybrid footprints makes the technology divide and kind of the locality of data a little bit more interesting. Are there any key things that you're seeing either being deployed organizationally inside of companies to kind of get their arms around this? Any things that you see that are working, or maybe even things you see that aren't working really well that you could provide advice on, fostering the collaboration and driving to that value proposition?
Yes, actually, that's a great point. I mean, again, to a great extent, and it sort of ties in with what I was just touching upon. So to a great extent, it's a cultural thing, really. So to make your organization data-driven means, first and foremost, that you have to sort of depart from hierarchical, top-down decision-making that's based on authority, let's say. So you have to open up to the fact that, well, someone that's not necessarily on top of the hierarchy may use the data and come up with something great, and you have to promote that. And actually, again, I have had the chance of speaking with some of the people that implemented that in Facebook. So we all know that Facebook is under fire today for many reasons, but one thing we have to give them credit for is actually popularizing this data-driven culture. And so the people that actually did that in Facebook used a mixed approach. So on the one hand, using the technical infrastructure that enabled them to provide access in a similar way, actually, to what we saw being mentioned in the keynote today from the German insurance company. So basically giving base access to everyone, but that was only part of the equation. The other part of the equation was actually empowering people to step forward with their findings, and that's actually maybe the hardest part. The book, they have written a book about that, which is a very interesting read in case you want to find it. It's called DataOps, and actually it gives a very good description of their journey, and I find it's a good term actually to describe this philosophy as well.
I think just adding on to what you said, and maybe talk about some of the things that aren't, well, the things that work well are oftentimes finding the right use case to actually start off from. I think what I've observed sometimes is oftentimes there's a technology decision which is let's deploy like, you know, a Hadoop platform and that's it. There's no rethink about the data strategy, architecture, or delivery approaches. So one of the reasons why sometimes engagements aren't working as well is, for example, you may have deployed a Hadoop-based platform, but then if you're imposing a linear architecture, which is very much sort of waterfall orientated, deployments aren't going to work. Because again, to do different kinds of machine learning use cases, I think the intent really is to have more iteratively published pipelines. So you can't necessarily presuppose how you want to structure and form the data. So this notion of minimally curated data sets, which you can then assemble for different use cases, needs to come into play. And that challenges the way organizations have done data modeling and data architecture. So that's, for example, just one aspect. Then in terms of, for example, doing testing and trying to automate a lot of that to really move pipelines through production, that's again something organizations aren't necessarily used to doing. So to your point, there needs to be a top-down change which says, actually, we might set up an incubator unit that is going to combine, for example, the engineers, data scientists, and actually prove out what's the right collaboration model, what's the right delivery approach, prove out a use case, and then start baking that out. And then you can go off tranches of additional use cases and deploy that. But that does require, for example, breaking through typical organizational barriers, having more pragmatic rather than very policy-oriented governance. So unless there's the right sponsorship, which is very business-led, and a use case you can prove out and get the early wins, oftentimes investments in technology are going to fall by the wayside.
Yeah, I mean, all great points. I don't have, again, that much to add. I guess the way I think about it generally is in terms of a governance framework. So when you talk to an enterprise, usually you could, again, it's a taxonomy, but you can divide it into people, technology, and processes. So you've got your technology side, which we talked about a little bit, with you can have a data management tool in place. There was a talk earlier in the major keynote about data catalog and metadata. So that can be used for better governance of your data on the technology side. And then, of course, you have the people side, which is the core of the question that was asked. I guess, to your point, the innovation can come from anywhere in the enterprise. The only thing you need so that everything does not end up being completely scattered across your organization is just an overall view of how your data is used and shared within your organization. So it doesn't have to be top down, but you still need, in my opinion, a view of how it's used through your CDO, Chief Data Officer, or a position high up enough in the hierarchy that you can at least feed back to the C-level, so CEO, CTO. And the last thing that ties all this together are processes. So as we talked about, collaboration is probably key. So not only do you need the technology to enable that, we talked about that, data management and collaboration tools, you need supervision, ideally at a high enough level that you can influence decisions, but you need the processes to back this up. So communication channels between your different teams, and also initiatives across the enterprise around data where everyone is involved, hence incorporating insights from all across the organization.
Great. Yeah, these are great insights, and again, it seems like there's a lot of consensus brewing here. So it feels like we're converging there. We talked about cloud. We talked about ML and AI briefly, kind of the hot, hip things to talk about. We missed IoT. So why don't I throw that into the mix and kind of get your thoughts on the market and kind of what's going to happen next in that space that's going to be important for our folks to keep in mind.
I mean, I guess the key thing with IoT is essentially it's already generating much more data, and it's a lot more distributed and scattered across the IT landscape. So I guess key innovations are coming. We talked about it a little bit with analytics at the edge. So both the ability to store and analyze at the edge, but also feedback and cross-tabulate those results and that data with data you might hold either in the cloud or on-premise, but in a more centralized way. So I think IoT is generating more data. It's going to yield insights, especially with advances currently made in streaming analytics and the ability to cross-tabulate that with data at rest.
I think one of the terms I've seen used is the notion of a data supply chain, so how data is moving, for example, from origination all the way through to consumption. And I think now with IoT, the boundaries of what a data supply chain is and the organizational data boundaries have actually been challenged. And I think it's leading to some fairly interesting sort of architecture thinking. Again, rather than the monolithic architectures of the past, linear pipelines, it's more about what's the right place to actually initially store and process, filter out the data, and then pass it on for deeper analytics. So I think there's some fairly good patterns emerging there. For example, to do, and I think HDF and Minify is a very good example of a technology stack that can help there. So where do you actually filter out the noise, maybe do some localized analytics, pass it on, for example, to a centralized cluster, add on, for example, historical trends, and then be able to generate the right kinds of alerts, and then have a feedback loop back into the point of intervention where action can be taken. So I think we're seeing some very good innovation come out there. Some standardization, at least in terms of product. So we see, for example, Kafka becoming quite central to as the scalable sort of pops up in there. Different streaming frameworks, some very interesting technologies coming out there. So not a lot of standardization in terms of tools, but at least in terms of the data patterns, the architecture sort of guardrails. I think there's some good sort of reusable assets coming out there. So I think that's very positive in terms of how the data can actually be harnessed for some proper use, and rather than just sort of handle a lot of the noise that does get originated at point of origin.
Yeah, I'll pick up from what you mentioned on in terms of standardization. So actually there is a little something there. So there's something called Apache Beam, which comes from Google. But you're right in the sense that, well, it's not really a standard. It's sort of, I don't know, archetype or whatever it is you want to call it. It's not seeing great adoption though, and it doesn't have to do with whether it's good or not. It has to do with vendor competition, basically. But you are definitely right in terms of, there's plenty of platforms there, and there's even more emerging. So, for example, there is a Kafka competitor. There's like a new Apache project that's been spun out called Spanner, and it's still the Wild West kind of period, let's say there. Even though Kafka seems to be like well established, there's much of competition in the other areas. There's just one thing I wanted to briefly touch upon. So, and that has to do with, well, defining IoT and its relation to streaming. So typically when we think of IoT, we think of streaming and vice versa, but that's not necessarily the case. I mean, there's other use cases for streaming as well. And even though most people would not think of it when we talk about it, ad tech is one of those, because you have a constant huge flow of data coming in, at least for big players. And one of the interesting discussions I've had the chance to have lately was with founders of Meta Markets, which has now been acquired. It used to be actually, because it's now acquired by Snap, one of the leading companies in ad tech. And what I took as the takeaway from the discussion I had with them was that part of it was how much they use streaming and what for. And they said, well, we use it a lot. We use it both upstream and downstream. So we use it to collect data from Facebook and Google and all the big ad providers. And we also give it as an option to people that subscribe to us. The thing is that most of the people that subscribe to us are not really ready to use it in terms of infrastructure. So while it's there, it's not really being used to its full potential.
Great, and I repositioned because we're getting down to the last couple of minutes here, so I thought I would see if there's anyone in the audience that has a question. Okay.
Good morning. Yeah, I'd like to get the opinion from the panel on the Open Metadata Standard Initiative. Right now it's IBM, Hortonworks and ING, and I think we all realize that we need a standard like this, but what's needed to make this a global standard?
Well, I think Mandy spoke about this at Strata a couple of months ago as well, and I think it's come along some ways over the last couple of months, and I think it's a really good initiative. And as Accenture and some of the other sort of large SIs, I think quite a few of us are looking to get involved as well. And I think with we've talked about cloud, IoT, and so forth, and again, the areas where data are going to be originated, processed, and accessed are going to be more and more dispersed. It's going to be a hybrid ecosystem going forward. And assuming that we'll be able to physically integrate metadata in a physical repository, I think is beyond the stretch of imagination, my imagination at least. So therefore, I think these kinds of initiatives are really important. And once we've had the likes of, for example, PMML for modeling, I think we need a standard like that for metadata exchange as well. So I think it's a step in the right direction. And to the extent that we start seeing more sort of use cases being ported across clouds, and for example, data plane services coming into the mix, I think the need to have metadata exchange is going to become more and more important, and I think we will start seeing it increase adoption.
Yeah, just to add on to that, I guess if the question is what's needed to make it work, the key answer I would give you is adoption. Usually the more people you have that adhere to a standard, the more weight it gains. And it's also usually exponential. So the more companies follow that standard, the more companies bandwagon on that standard too. I guess the one point that we didn't mention is the tricky point from a data standpoint is given the variety of formats that your data comes in, is trying to have a common metadata standard for from all those different types of data is also tricky. So I guess it also takes a little time from a technical perspective, but given that we're getting there, I don't see why we wouldn't see a high take-up or increased take-up.
And I'm not officially a panelist because I'm a vendor, so I have like a vested interest, but I appreciate the question because certainly we think it's a really important thing to get the community together to adopt some standards because, so to everyone's point, if there's no standard, there'll be bedlam, and in bedlam, there will be a loss of value, right? And so certainly we're happy that lots of partners have jumped in, and our goal really is to continue to leverage that open community to try to drive some semblance of consolidation in that space, regardless of any of the commercial implications that it might have. Hopefully it'll be good for applications that could be built.
So a follow-on question around metadata, right? So I'm coming from the DevOps world, right? And so thanks for the data ops word today. That was awesome. But question, I guess, related to the DevOps space, right? Are you familiar with Grapheus, which is a Google JFrog? Basically, it's metadata about developer application artifacts, right, from open source code all the way to production. And how do you rationalize those two? Or are they unrelated, or do you see them coalescing?
Can you say the name of the framework? Grapheus. No, I'm not familiar with that, but yeah, I mean, I definitely see the relation in terms of, if I want to be super generic, I'll say, yeah, it's also metadata, but actually, that kind of, I think that's a very good use case. So getting description of what the different components are and how they can be tied. Exactly, that's a prime use case for metadata, I would say. And that's just one of the examples of what you can do with metadata. Actually, my background is in metadata as well. And to give you a kind of similar use case, let's say, so you probably know schema.org. Right now, it's quite prominent, but it didn't get there overnight. I mean, people have been battling to get a consensus on what the terms should be and where you should put them, and actually battling to gain support from the likes of Google and Yahoo for years. So I don't, to come back to your question, this is not something that I expect will happen overnight, but hopefully it will happen.
We hear this a lot about moving from MapReduce into Spark. So I just want to get your opinion and to see if it's really real. And what's your take in using object-based storage? Whether, I mean, we know the cloud probably be object, but on-premise as well for Spark workloads and the rest.
Okay. Yeah. Personally, I think it's quite real. Actually, I mean, again, it's one of those things like the cloud, for example. So if you listen to Analyst, for example, they'll tell you, oh, everything is going cloud. But you saw the survey this morning that showed otherwise. So yes, it is happening, but no, it's not as drastic as people may have you think.
So I think in terms of adoption of Spark, massive uptick over the last, I would say, 24 to 30 odd months. And I think one of the reasons we're seeing a lot more interest in even driving the adoption of Hadoop platforms is the advent of Spark. I think personally, in terms of storage architectures, we'll talk about the object stores in a minute. I think the interest in the battle now is actually in the compute and processing framework side of things, and I think that's where a lot of innovations happening that are actually allowing a lot more interesting micro-batching machine learning use cases, and I think Spark's at the forefront of a lot of that. I mean, there have been some interesting announcements recently from Databricks as well on Azure, or been on AWS for a bit. So there are, I think, now some interesting alternatives in terms of how you actually set up and deploy a different set of machine learning use cases, choices of object stores, HDFS, different processing frameworks. So I think as architects and engineers, it's going to be a fairly interesting space, and I don't see any, I would say, standards evolving in the short term. For MapReduce, there's still going to be some, let's say, some fairly compute-intensive, longer-running workloads where it still might be around. But I think Spark is definitely getting a massive amount of traction, with Scala and especially with PySpark. And I think object stores have, I would say, some good benefits in terms of obviously utilization in the cloud, less so in terms of object store concept on-prem. But I think quite a lot of the vendors in this space are actually getting some of their Apache open source projects to work directly with, for example, the object store. So I think we're going to see quite some interesting shake-up in this space. And then as sort of PaaS-based offerings come into the mix, how does that work with IaaS? I think there's going to be a lot of work for the engineers and architects here to work out for a given use case what's the best sort of pipeline that we can actually construct.
Just to add to an earlier point, I mean, it would be false to say that everything is in the cloud. Obviously, the journey, as I was saying earlier, it's still just at the beginning. I think the poll we did earlier in the keynote was fairly accurate. We run a survey every year, and we had about the same results. About 25% of the workloads are run in the cloud. When you ask enterprises, they say, yeah, about a quarter. So, they definitely don't run everything in the cloud. They don't store everything there. And I was saying, sure, we're going to see an increased amount of data in the cloud, but there is probably a lot of that data that will stay on-prem both for privacy reasons and for regulation, I was saying earlier. And a lot of industry have a lot of interest in keeping some data on-prem.
All right, good. In interest of time, we're down to just the final 5 minutes. So I have one final prepared question for you all, so you can all breathe a sigh of relief. And that is, what didn't happen the way you thought it would? What surprised you? And what do you think you'd recommend we keep an eye out for coming in the next 12 months that might surprise all of us?
Now, you guys are gonna laugh. I was gonna say I think we were too keen on the move to the cloud. That was my prepared answer. And I stand by that. I think, I mean, in my own opinion, I thought the take-up would be faster. Now, what do I expect to see happen in the next few years? Obviously, more workloads, more storage in the cloud. That's one. I guess the other one is also that kind of platform approach that a lot of vendors are taking at the moment, and trying to embed all those applications together to give you both a common look and feel across your platform, but also the ability to integrate analytics within your different core enterprise applications, and so on.
I think the thing I've been disappointed about was the success rate of big data deployments. I would have thought that we would have learned from some of the mistakes made in the past in terms of data warehousing deployments, and set up the right kind of, let's say, architecture guidelines, flexible architectures to be successful on Hadoop. I think some of that is turning around now, but it's not led to as much of a successful track record as I would have hoped. And then in terms of where the future is going to, as I was saying earlier, I think there's going to be just so many different processing frameworks, innovative technologies coming out there that it's not going to let any of the sort of engineers and architects here actually rest. We have to keep looking out for what's coming down next in terms of some innovative frameworks. You talked about Apache Beam, been tracking Apache Arrow. I think that's going to be quite interesting as well. There's some very interesting both open source and technology vendors that are helping to push BI workloads towards the likes of Hadoop. So I think what will have to change is, again, bringing sort of this microservices architecture thinking, which is use case by use case, what's the best fit of the different sort of storage, processing, consumption patterns, and then what's the right tooling that I need to bring in there, whilst looking at, when should I use PaaS or IaaS, cloud portability versus lock-in. So it's going to make for a very interesting, I would say, dynamic. And I think what that's going to also force is different teams and skill sets having to come together, and that's going to challenge the way I think organizations have been set up across boundaries. I see that in the way we bring teams to bear as well. So it's actually mixing, for example, the data ops person, the engineer, the scientist with the product owner. And I think the one thing I would suggest will be quite interesting to consider is, rather than look at data projects, really looking at data products and bringing a product management view, which is you want to build out a data product, develop features iteratively, and take that approach. I think is going to be quite interesting going forward.
Yeah, all good points. So I'm not going to add anything to that, just going to go in a totally different direction, and I'm going to leave you with 2 words: graph databases. And it's something that's quite near and dear to me. It's something I've been working on years, and something that's also been quite a niche up to now. But then this year, 2 things happened that even I didn't see coming. So basically, Microsoft and Amazon entered the space, and then interest kind of went through the roof. And use cases have been there for ages, and databases and vendors have been there for ages. Frameworks to work with Graph on Hadoop as well have been there for ages. But suddenly now, when you have this kind of node, let's say, everybody thinks, oh, okay, so this is the next big thing. Maybe it is, maybe it's not, but it's definitely something interesting to keep an eye on.
Very good. Well, if you would please join me in thanking our panelists for their advice and insights today.